Hi, my name is Abu Francis, and in today's topic, I will be discussing about how knowledge is very dynamic and why is it that we need to understand that knowledge is dynamic. Now, one of the impressions which many students have and many adults also have this is that knowledge is static and it applies equally well in all situations. But the reality is quite different. Let me give you an example. And this is one of my favorite examples because it really highlights the misunderstandings which young students and fresh architects and many people have this, which is to do with climate and how one of the most crucial features of climate, how it works. Now, when we were in 7th standard, in 6th standard, and probably earlier also, we were taught that the sun rises in the east and then sets in the west. Now, let's examine that and why is it that this particular piece of knowledge is not as simple as it was taught to us. And I'm actually surprised when I ask this question to young, fresh architects. They don't really understand why should it be any different because sun rises in the east and sets in the west. Well, let's examine that. So say I have this smiley ball with me, and let's say that this particular scene which you see here is the equator. Now let's say that here is a sun. Okay, let me just see whether you can see. So here is the sun, and the sun is sending its light off onto the earth. Now the distance between this smiley ball and my fingers here, which represent the sun, is very short, and therefore you can imagine the light going like a conical way. But in reality, we all know that the sun is huge and it is very, very far away, and therefore that cone, it does form a cone, but then the angle is so small that all the rays of light, they are all coming in parallelly onto the earth. Now let's say that the plane which contains the earth and the sun, that plane, I'm simplifying a lot of things even now, and if this particular earth was rotating exactly vertically to that, means perpendicular to that plane, so this is rotating like this and the sun is beating down on the earth like that, then this particular ball would have exactly half of it will be in light where it's facing the sun, and the other half would be in shade, which is the night. So one side is day, the other side is night, and obviously the earth is rotating, right? And now I'm assuming that the earth is rotating perpendicular to this plane, which it is not, but for a moment let's assume that it is doing that. And then what happens is that then at every instance of this rotation, the earth is perfectly one side day, the other side night. Now if you work on this a little bit more, you will understand that if this was the case, then you can give credence to what we thought was a fact, that the sun rises in the east and always sets in the west. But that's not how it happens. What happens is that the earth is tilted with respect to what? When I ask tilted to what? It's free floating in this universe. So what is it tilted to? So it's tilted to the plane of that orbit where the sun is in one corner. So that particular plane, it is tilted to that at approximately 23 degrees or so. Now when the earth is rotating, there will be unequal parts which will be in light and in shade, that is in day and night, and therefore the chances of it, because it's not just rotating, it's also revolving around the sun, right? It is going around the sun like that. So you'll have to take a pen and paper and work this out. It's very easy to understand, and you'll find that this one rotation of the tilt of the earth, that is not fully internalized. We have not recognized that. Anyway, this was just an example. I'll probably make some more videos on how to understand climate and how to understand the sun. Many religions worship the sun because it's truly a constant, and thankfully so. Because if the sun kept disappearing literally out of space, we wouldn't have life. And that's the reason why many religions, they worship the sun. Worship is not something which I really believe in because I'm an atheist myself personally, but I can understand the serious importance of the sun. Similarly, the tilt of the earth is also thankfully one major contributor to this lovely sets of seasons which we have, and the way the sunrise and sunsets happen at different times, and why we have unequal days and unequal nights, and there are only 2 days in the entire year where you have exactly 12 hours of night and 12 hours of day, and that only in certain parts of the earth. Now all this will be discussed separately under when we talk about climate. The point today is to convince people, that convince youngsters mainly who are coming up as an architect, is that an architect cannot really think of knowledge without the context in which that particular knowledge has to be applied. Now why so? Because the knowledge of an architect, a good architect, can affect situations at the regional planning level, at the urban planning level, urban design level, at the neighborhood level, at the building level, and inside the building, at the room level, at the interior level, inside the room, at the furniture level, inside the furniture, at the drawers level, inside the drawer, the objects in the drawers level. Now to assume that all the knowledge which we gain, they are going to be static and they don't have any further detailed explanation, is one of the myths which I need to remove from students. That we need to understand that knowledge is like that proverbial onion with multiple layers, and then you need to peel off those layers and then understand that why a certain approximation was made when we were in school and we said that the sun rose in the east and sets in the west. But then as we get older, we realize that there are other nuances of that, and why it's not always exactly east and it's not always exactly west. And why so? Why is it that it is happening twice a year? And why is it not happening thrice a year? And what would have happened if the same situation was to be examined on, say, on the moon? Because some of you youngsters may actually be designing architecture on the moon, or maybe on Mars, who knows? And what is the kind of situation by which what is the kind of context which you would want to understand all these subjects? So you have to keep your brain alive to know that things are not as easy as it seems. It's not that one size fits all and then just keep using that. There's a very interesting story which I should tell you about Galileo, and he was quite famous for his wisdom and his knowledge and all that. And you should search on the net for a particular article. Just search for the words parabola, catenary, chain, and Galileo, and you should be able to read this particular article. I don't have a chain with me, but let's assume that this USB cable is actually a heavy chain, and if this chain was hanging on the wall, okay, and on 2 points, and then you get a curve there, right? I mean, this is a very poor curve because it's not really a chain. It's not. It's a little rigid in parts and flexible in parts, and therefore it doesn't behave like a proper chain. But if this chain was of uniform linear mass and it was hanging on the wall, and somebody say, okay, tell me what was that curve which is being formed there. Now, we have learnt about conic sections and we've learnt about circles and all that, and then it will be quite natural for us to say that that's a parabola. And that's what Galileo also said, that it's a parabola. But turns out that Galileo was actually wrong. That curve is a little esoteric one. It's called a catenary. Actually, it's not very esoteric, but it's not something which we have really learned. Now, what's the difference between a parabola and a catenary? They are actually, if you really plot them, you could have a catenary which is quite coincident with a parabola. So Galileo can be forgiven for it. A lot of us will say that that's a parabola, not a catenary. Now what happens? So you got this curve. What's the difference is only towards the ends of that particular curve you'll find that actually there's a variation, but otherwise most of the curve is indeed like a parabola. Now why should this matter? Let's take another hanging chain example, which is a suspension bridge. Now somebody will say, okay, now we understood how Galileo was misled and he misunderstood and he thought it was a catenary. And let's now start talking about the suspension bridge and what is the curve there. Turns out that you would say, oh, that now here I got deceived. So obviously that's also a catenary because that's also a hanging chain in one sense. But no, that is not a catenary. That is a parabola. Now why is that a parabola and a regular chain is not a parabola, it's a catenary? Now that's where it becomes very interesting, that you need to start thinking that, okay, why is this particular curve of a chain a catenary and that curve of a suspension bridge is actually a parabola? And that's because the suspension bridge has got the deck of that particular road or railway line or whatever that particular mode of transport is, and then that particular deck is very heavy, and to support that there are wires coming down from that chain to support that particular deck. Now how does that work and why should that change the nature of that particular curve? And that makes it very interesting that you know so here are two different situations where in one case you thought it was a parabola but it's a catenary, and in the other case you thought it should have been a catenary because earlier it was a catenary but actually it's a parabola. Why should this matter? We are architects, we are not supposed to use maths. There is this kind of myths which people have about maths and geometry and all that, but the sad reality is that finally you may be involved in some building or the other where you have to actually plot this particular curves because that's the design and the design needs that. And if you thought it was a parabola and when it should have been a catenary or the other way around, then there are going to be serious errors, right? You have to construct that building over there or that part of that building. And to understand these geometry not as some fixed pieces of knowledge, but to understand knowledge contextually and in layers, and to understand where the boundaries are and where a certain piece of knowledge is applicable and certain pieces of knowledge which you thought was applicable is actually not applicable. That is where you really grow up as a designer, and you need to internalize and be comfortable with the fact that things are buzzing around, they don't ever really settle. I wouldn't be surprised that there could be bridges which should have been a parabola, but then it again turns out that it was indeed once again a catenary. And maybe for all you know, you should do that as an exercise and tell me about it, and tell me that what could be a bridge which should have worked like a parabola but ended up as a catenary once again, or maybe some other kind of curve which was there. This is why architecture is a very fascinating field. It is not something which you just learn once and then you learn some formula or whatever, and then you go and apply it, and then you say, okay, I've done, it's all sorted, it's all done and dusted and everything works out. That's not how it is, and that's where you youngsters would actually have an advantage, because you can actually apply your brain and keep that brain buzzing around in many different contexts. So this was just a feel of what kind of material we plan to put up at archopus.com, where in this particular case I was trying to build the case for knowledge as a dynamic system, not something which is static. So thank you so much. I hope you enjoyed this particular small talk, and I hope to see you in my other videos. Thank you so much. Please do join archopus.com. We are going to launch that very soon. Thank you.